For people unfamiliar with you, please just tell us your name, your background, and really what you've been doing for the last several years.
Sure. Well, I'm Mark Serreze. I'm a professor in the Department of Geography in the University of Colorado, Boulder. I'm also the director of something called the National Snow and Ice Data Center, a center of about 95 people doing all kinds of work on snow and ice. My own background, I grew up in Maine, got interested in climate science, back in my early 20s, and I've been doing it ever since then.
What is your book about, Brave New Arctic, the untold story of the melting north?
Well, my new book, Brave New Arctic, it was a book that I really wanted to write for a long time, finally got the opportunity to do it. And it's a story about how the Arctic transformed from an Arctic of old that the explorers of the 19th century would have recognized to something that is becoming very different today. And it's a story really about science, scientists, and how science is done, how scientists from around the world came together to try and understand these changes. So it's a lot of it is a personal history, my own history of trying to understand what was happening, but also bringing in the stories of many, many scientists who I've worked with through the years. So it's really a story about scientists and how science is done.
Can climate change be reversed? And if so, how?
Well, certainly climate change could be reversed. Now we have to remember that climate has changed all through Earth history. It's changed on periods of maybe decades to centuries to periods of tens of millions of years. Climate has always been changing. This recent climate change, though, has a different cause than climate changes of the past, and that's because we're adding greenhouse gases to the atmosphere through fossil fuel burning. Can we stop this climate change? Absolutely. Stop burning fossil fuels. Now, it will take a while for the climate to get back to where it was, because the problem is the carbon dioxide that you've got in the atmosphere today, it'll stay up there for a long time, really in the matter of centuries, so this wouldn't be immediate. But yeah, we could get things back to where they were. It really all depends on us.
Specifically, can we remove greenhouse gases from the air?
Removing greenhouse gases from the air, well, there's been a lot of research being done on that, what we call sequestration. In other words, if you're burning coal, for example, pull the carbon dioxide out before it even has a chance to get to the atmosphere. There's a lot of work on this, different technologies, but it's something that would have to occur on a massive scale. I would think that our smarter option now is just to go to better ways of producing energy and let that carbon dioxide come out of the atmosphere. On its own. We can live with some warming, we already are. We can live with some warming, we're committed to that. The real challenge is making sure it doesn't get out of hand.
Guy McPherson is very pessimistic about humans surviving even 10 more years on the planet. What do you think?
Well, I think that's rather pessimistic. We are a remarkably adaptable species. Humanity's been through a lot and we've survived. We'll live in a warmer world if we have to. Well, we're already going to live in somewhat of a warmer world, even if we do nothing right now. But we are remarkably adaptive. But it'll be a different world. We'll be leaving our children and grandchildren a different world, a world that is really not as robust, not as good. But we'll survive it. So I'm not nearly that pessimistic. We are a remarkably adaptable species.
How close are we to irreversible feedback loops that'll speed up climate change?
Well, you talk about these feedback loops. Some people call them tipping points. That's a word that you commonly hear. That you get to some certain point and then bang, things fall apart. Certainly the concept of tipping points or irreversible damage is certainly valid. But what I see in terms of climate change is that it's an overall warming with a lot of ups and downs because there's a lot of natural variability in the system. And that's kind of the trajectory we'll go on. I think probably the bigger danger, from my point of view, in terms of what we call tipping points, is in ecosystems, for example. You deplete the oceans, you deplete the fisheries, microplastics in the oceans. These are the sorts of things that could cause something like an ecosystem collapse. I think those are the things we really have to be thinking about.
How likely are we to experience food or water shortages due to climate change?
Well, in terms of some of these effects of climate change that are affecting people, food, water shortages, you're already seeing it at some level. For example, the people who live in the Arctic are already dealing with climate change. It's a frontline thing in terms of losing the sea ice, which is changing their hunting practices. So this is something that we're already seeing, and we'll probably see more of it. The general, what we're looking at in terms of the projections, in terms of like rainfall changes, the rule of thumb is the areas that are dry are probably going to get drier. The areas that are wet are probably going to get wetter. So if you're living in an area which is already semi-arid or something like that, yeah, you're at risk. Even if there's no change in precipitation, the fact that it's warmer means that there's more evaporation, which means that there's more drying. So this is very much something of concern, because this puts us at risk, not just us, but ecosystems, entire ecosystems. But it's among the challenges we're going to be facing. Again, it goes back to the issue I said, that we can live with some warming. We're going to have to live with some warming. Got to get a handle on it before it gets before it gets too big.
How long have you been studying climate change?
How long have I been studying climate change? Well, really, in a formal way, I guess you'd say, probably 22 years old I was back then. So that was 1982, so what, 30, you do the math, okay? But it's been quite a while. I'd always been interested in weather and climate. I grew up in Maine, where we had real winters, and I loved snow and ice. So I was always the one that was watching the weather and things like that. But it was kind of in my senior year of college that I really started to get interested in it. And it was right after I graduated that I got my first opportunity to travel up into the Arctic. And I stepped off that plane into the Arctic and looked around and said, my gosh, this is what I want to study.
Do you live in Colorado now?
I live in Colorado now. I grew up in the state of Maine, in Kennebunkport, Maine, actually. And then I moved to Colorado in 1986 to get my doctorate. I never left, so I became a Westerner.
How often do you get to the Arctic yourself?
I've been getting there, I've been up about, for different expeditions, about 15, 16 times. I haven't been for a couple of years, and it's just the way schedules have worked out and things like that, but I will hopefully rectify that deficiency in the next year. And the way I see it in terms of, I got to get up there because you got to have street cred, right? You got to hit it with your own hammer.
How much of an impact would it make if everyone stopped eating meat?
If everyone stopped eating meat, it would have a tremendous impact. We could benefit greatly by just eating lower on the food chain. If you look at the energy requirements to raise, a cow, right, or steer, it's immense. And we'd be much better off not eating the cow, but eating the things that the cow eats, for example. The same thing with a lot of different animals that we raise. We could all go much better off by eating lower in the food chain because of the energy requirements.
How much time do we have before climate change makes growing food and living on the planet just too difficult?
Well, I think that's kind of a loaded question because you can always grow something. At some level, carbon dioxide acts as a fertilizer, right? You can actually, this is what plants take in, is carbon dioxide, but that only works to a certain level. Crop habits may have to change. Agricultural habits may need to change. What used to grow here might not grow here, so you have to grow something else. I don't see that we're looking towards some situation where you can't grow anything. I mean, unless the earth started to boil or something like that, and that's not going to happen. But agricultural practices will change, and we'll have to adapt to that.
If everyone cooperated and agreed to work together, are there technologies today that can remove greenhouse gases from the air and stop or significantly slow down climate change?
Well, as I mentioned before, there's a lot of research on what you call sequestration, right? Take the carbon dioxide out before it gets out of the smokestacks, things like that. There's a lot of ideas out there, a lot of work out there. It would be a very difficult thing to do. Again, I think I said it before, I think the smarter option is to just reduce your greenhouse gas growth by going to different ways of energy production. And if we do that, the climate will come back to what it was. If we could get a handle on our greenhouse gas emissions right now, We'll be living with a warmer planet, but a planet that we can handle. We'll still have an Arctic sea ice cover. We'll still be okay, but the issue is getting a handle on it now, otherwise it's going to catch you.
If nothing changes in the way humans live, what do you believe the planet will be like in, say, 2029, 2039, 49, 2059, or 2069?
Well, if we can continue going on this path we're doing right now, sort of like a burn baby burn scenario, yeah, you're looking at a warmer and progressively warmer world. We're going to be looking at some areas with shortages of food and water. You're going to be looking at higher sea levels. You're going to be looking at probably having to shift agricultural practices. So again, it's something that we'd leave our children and our grandchildren a planet that is less habitable. But again, we can stop this. We can put a halt to this. It's going to take a while. It doesn't happen overnight. But let's not throw up our hands and say all is lost, because it's not.
If there was unlimited money and total cooperation between countries, what technologies, solutions, products exist to reverse climate change or take greenhouse gases out of the environment?
Well, we've already talked about taking greenhouse gases out of the atmosphere, but in terms of limiting your greenhouse gas growth, at this conference we've heard a number of solutions. Solar. I mean, solar power is just growing in leaps and bounds, and wind. Now, wind energy is basically secondhand solar because, of course, it's the sun that eventually drives the wind, so it's secondhand solar, really. Those two alone have tremendous potential and are growing in leaps and bounds. Out in Colorado, where I live, we have big wind farms. Well, no one's doing that out of altruism. Someone's making money on those, but it's part of the solution. And the other thing, we can be so much more efficient how we use energy. We've already made inroads in that. We used to have incandescent bulbs. Now we've gone to LEDs, which are so much more efficient. We're on a better path in that way. We just have to pursue these paths much more aggressively than we are today.
Richard Oppenlander and others say the most powerful thing we can do to stop climate change is stop eating animal products. Is this true? And if so, why aren't more people speaking about this?
Well, yes, if we stop eating animal products, it would be a huge improvement, because I've mentioned before the energy requirements to raise, say, a pound of beef or something like that is just tremendous. So we'd be much better off in doing that. How that would compare to other measures, like going in terms of electrical production for solar, wind, I can't say. That's not my area of expertise, but absolutely it would make a huge impact. Well, in terms of the energy production, say, to raise a pound of beef, so what do you have to do? Well, first of all, you have to grow what the cattle are going to eat, which is usually corn, feed corn. Well, of course, you've got to plow your fields, you've got to plant those fields, you've got to raise that, a lot of chemical fertilizers, a lot of using that, nitrogen. Then you've got to harvest that all, and now you've got to ship it all to your cattle, which then eat that. At every step of the way, it's very energy intensive to do something like that. Where does that energy come from? Burning gasoline or something like that. So there's all these different steps in the production of beef, all of which take a lot of energy to deal with, and that's where the problem lies. If we instead just ate the corn directly, not that it's really good corn to eat, that, it's cattle corn, but you get what I mean. If we grew the plants and ate those instead of using those to feed the animals to produce the meat, we'd be a lot better off.
Tell me how you see the next 30 years if nothing changes in the way the world produces greenhouse gases.
Well, if nothing, let's just say, I think the question is that what will happen in the next 30 years if we really don't do anything about our greenhouse gas growth? And as I mentioned before, we're just looking at a progressively warmer world. We're looking at the Arctic sea ice cover probably disappearing in summer. We're looking at a higher sea level because the Greenland ice sheet, the Antarctic ice sheet, Arctic and Antarctic ice caps and glaciers will be melting down. We'll be seeing some areas with intensified drought, some areas with intensified precipitation events, increased forest fires in some areas. So basically, in a sense, you see sort of weather on steroids, in a sense here. And that's the path that we'll be on. In terms of things like more intense droughts, more intense precipitation events. We have to remember that in a warmer atmosphere, you can hold more water vapor in the atmosphere, so you're going to have an intensified hydrologic cycle. You'd say, well, it rains a lot out here. Actually, it makes it drier out here for some of the same reasons. So it's a complicated thing, but that's the path we're going to be on.
What action should we immediately take to stop climate change from progressing, and is that even possible?
Well, as I mentioned before, yes, we can stop climate change. It's not going to happen tomorrow. It's not immediate. It will take time. See, the problem is that carbon dioxide we put in the atmosphere stays there for a long time. And so as long as it's there, it's going to keep us out of what we call a balance, a radiative balance, and the planet will keep heating up. It takes a while for that carbon dioxide to be drawn out of the atmosphere. But if we let nature take its course, it will draw it out of the atmosphere. We just got to give nature a chance. And that means stop loading the atmosphere with carbon dioxide. If we can do that, the planet will come back. And it's not too late. We can do that now. It'll take a while, but we'll be okay.
What are the most important steps humans can take to stop climate change?
The important steps that humans can take to stop climate change is changing your power production. For electrical production, you need to go solar, you need to go wind. Now you talk about something like nuclear, okay? Nuclear is a very controversial issue because you have to deal with that nuclear waste. But I'm a pragmatist. I say choose your poison. What's worse? You burn fossil fuels and you put carbon dioxide in the atmosphere, or you deal with nuclear waste issues. Choose your poison. The point is nothing comes for free. Even building solar, even building wind takes energy to do that. It's not a matter, there's no magic or what you call silver bullet here. What we have is intelligent choices that we can make. But going to solar, going to wind, changing how we eat. We talked about going to eating lower on the food chain. And very, very important, simple conservation. We can be so much more efficient on the energy that we use. Those things in combination, if we could do that as a species, we're going to be okay.
What are the results of climate change so far in terms of its impact on conflicts between countries, shortages, and why does this matter?
Well, you're seeing, from what I understand, I'm not an expert on this, but in terms of how climate change is related to growing conflict, there's hints that it's emerging in some areas. My specialty is in the Arctic, and what you're seeing up there is that climate change and geopolitics are becoming intertwined. We see that Russia is really benefiting from a warmer Arctic because there's less ice. So what are they doing? They're going gung-ho in producing oil and natural gas because there's a lot of oil and natural gas at the bottom of the Arctic Ocean. With less ice, it raises possibilities of conflict. Our Navy, for example, is very much aware that we've got an Arctic now with less ice that they're going to have to deal with. Are we going to see conflicts arise? Hopefully not, but we'll see. And in many ways, the Arctic is kind of this microcosm, this kind of example of some of the issues that are now emerging where climate change and geopolitics get tied together. But we'll see. Hopefully, as a species, we've matured a little bit, and we'll be able to handle this.
What are the results of climate change so far in terms of its impact on extinction of other species, and why does that matter?
Yeah, well, in terms, if we change the climate, we are going to see some species that are not going to do well and may die out. It's already been happening. And we are going to see some that are going to do just fine, right? It's interesting that even if you look today, lots of different species have adapted very well to people, right? Squirrels, right? Crows, all kinds of things. Others not so well. In the climate change area, there's going to be winners and there are going to be losers. Again, my specialty is the Arctic. The Arctic vegetation is changing, tundra being taken over by shrubs, willows, things like that. If you're a caribou, you're saying, I don't like this is not good for me. If you're a moose that likes eating willows, things like that, they're saying, oh, this is fine, this is great for me. You see, there's winners and there's losers in this.
What are the results of climate change so far in terms of its impact on flooding and rising water tables, and why does this matter?
Yes, well, one of the things that we're seeing already in the United States, for example, there's very good statistics on this, that the frequency of what we call extreme precipitation events is changing, more precipitation extremes. And this goes back to what I said before. We're warming up the atmosphere. That atmosphere can now hold more water vapor, but if it's going to precipitate, you've got to have water vapor in the atmosphere. So more water vapor in the atmosphere, the potential for bigger precipitation events. And there's good statistics to back up that this is already happening. So that does raise the issue of floods and things like that. On the other extreme, we also see areas that are dry are probably going to become drier. And so, for example, you look at the big wildfires out in the West. It appears to be a combination of things. One of them is poor forest practices. Another one is it's getting warmer, so it's getting drier. So you see these things connecting with each other. In coastal areas, of course, a big concern is sea level rise because we're melting the Greenland ice sheet, the Antarctic ice sheet, glaciers and ice caps around the world, and the ocean is warming, which means it expands a bit. And that contributes to sea level rise. We don't have to worry about it in Colorado, where I'm from, but if you're in New York City or New Orleans, Miami's already dealing with issues of sea level rise.
What are the results of climate change so far in terms of its impact on food shortages, and why does that matter?
Well, I'm not aware that we've seen a big impact so far in terms of food production or food shortages. I'm sure there are some issues that have already emerged, but I'm not aware that this has emerged right now in any big scale way. But it probably will become a bigger issue as the planet continues to warm. Agricultural practices will probably have to change. Again, it's interesting, it depends on your point of view. For example, in Russia, many Russians look at climate warming as a good thing because, for example, areas that are presently marginal for agriculture, for growing wheat, say, you say, well, now you're going to have a growing season that is 4 weeks longer. They're going to say, bring it on, right? So it depends, again, on your point of view.
What are the results of climate change so far in terms of its impact on increase of diseases and undesirable bugs that now can live in areas where it was previously too cold, and why does that matter?
Yeah, well, this is something you're already seeing, is that diseases that you didn't see in one area, now you're probably starting to see them increase. Malaria, for example. Yeah, as the climate changes and conditions, it warms up, precipitation patterns change, you are going to see the bugs, right, going into different areas that they might not have been before. So this is all, part of the many faceted aspects of climate change. It's not just that the planet is warming, all these other things change along with it. Very nonlinear.
What are the results of climate change so far in terms of its impact on increases in storms and dangerous weather, and why does this matter?
Yeah, well, something I've already mentioned is that as the climate warms, the atmosphere warms, it can hold more water vapor, something called the Clausius-Clapeyron relationships, understood for a long time. But with more water vapor in the air, it raises the potential for big precipitation events. For example, you've probably heard of the term maybe too cold to snow. Right? Well, there's truth to that, because if the atmosphere is very, very cold, it can't hold much water vapor. The big snowstorms, things like that, is when you're getting nearer to that freezing point, right? Because the atmosphere can hold more water vapor. Well, the same goes in for summer thunderstorms and things like that. So there's already good statistics out there that for the U.S., for example, that extreme precipitation events are on the rise. Very good statistics on that. And that raises the potential for flooding and things like that. Think about hurricanes, tropical storms. There's evidence that the intense ones are becoming more intense because there's more water vapor around and warmer sea surface temperatures for them to work with. Now, there's also the issues is that we've got a lot more infrastructure in the way on coasts than we used to have. So it becomes a difficult thing to figure out, well, is all this damage because the hurricane is getting stronger, or is it just so we've got a lot more people in the way than we used to have before? It's really a combination of them.
What are the results of climate change so far in terms of its impact on melting ice caps or glaciers, and why does that matter?
Well, of course, melting ice caps, glaciers, that's the sort of thing that I work with, being a climate scientist who specializes in the Arctic, although I've done some things in the Antarctic as well. Yeah, if we, when we think about the ice in the Arctic, there's really two kinds of ice we're talking about. One is floating sea ice. That is ice that is on the ocean. It's formed by the freezing of seawater. We're losing that ice fairly quickly, but losing that ice doesn't change sea level because it was formed by the freezing of seawater. If we're talking about the issue of sea level rise, what you're talking about is the meltdown of the Greenland ice sheet, Arctic ice caps and glaciers, the Antarctic ice sheet. And all of these ice masses are losing mass, because now you're taking what was on land, water that was on land as ice, and dumping it into the ocean, and that raises sea level. The other part of sea level rise is what we call thermal expansion of the oceans. The density of water, interestingly, is not constant. It's a little lower when we warm it up, so it occupies a little bigger volume, and that raises the sea level. Both things are happening right now. The oceans are warming, and we're putting more water into the oceans. Right now, the sea level rise is about 3.2 millimeters per year, something like that. Right? It's getting bigger, but it continues year after year. The sort of estimates right now is by the year 2100, maybe you'd see something like 3 feet of sea level rise. Maybe a little more, a little less, depends on the assumptions you make. How important is that? It depends on where you live. For example, if you live in Miami, you're already dealing with issues of sea level rise on particularly high tides. It's going to get worse. Area like New Orleans, it's going to be a problem because even a modest sea level rise associated with a storm surge from a hurricane is going to cause big problems. So again, the impacts depend on where you live. The Navy is very interested in the problem of sea level rise, and it makes sense because naval bases are at sea level.
What are the results of climate change so far in terms of its impact on ocean acidification, and why does that matter?
Yeah, well, ocean acidification, this is part and parcel of the absorption of carbon dioxide from the oceans. Now, the oceans and also terrestrial biomass, things that grow on land, are actually helping us right now. If we look at the carbon emissions to the atmosphere, we can calculate that pretty closely. And if we look at what the observed rise is in carbon dioxide levels in the atmosphere, it's only about half of what we expect. In other words, we should expect the rise in carbon dioxide in the atmosphere to be about twice what we observe, given how much we add to the atmosphere. Well, what's helping us is that a lot of that carbon dioxide is taken up in the oceans, and it's taken up by terrestrial biomass, things that grow. It's basically buffering us. Now, that won't last forever. There's limits to that. But the thing is, if we put all that carbon dioxide into the ocean, we acidify it. We get carbonic acid out of it. Well, the problem with that is there's coral bleaching issues. Of course, that's partly a warming issue as well. But calcifiers, mollusks, and things like that who build shells, that can interfere with that shell building. So there's a lot of impact here from ocean acidification that can certainly directly impact ecosystems, and that is going to eventually impact us.
What are the results of climate change so far in terms of its impact on temperature, and why does that matter?
Well, certainly when we think about climate change, what we usually equate that with the term global warming. And that warming, what we're really talking about generally is the air temperature near the surface, about that high. It's what we call screen level. And we measure those temperatures all over the world. And of course, those temperatures are rising. It's not an even rise. It's got a lot of squiggles in it. It's sort of like this sort of thing. You're going up, but there's a lot of ups and downs. That's the natural climate variability in the system. But we're seeing warming throughout the system. For example, something like 90% of global warming is actually in the oceans, because the ocean is a very good reservoir of heat. The atmosphere is not. But the atmosphere it's something that we measure. We've measured that temperature for a long time. It's a measure of something that directly affects us in terms of the warming, and that it affects things like agriculture. But I think the point to be made here is that the warming, just in terms of air temperature, that's only part of what is happening. We're warming the oceans, we're acidifying the oceans, we're putting more water vapor into the atmosphere. These are all part of the issue of climate change. So just fixating on the temperature part gives a very, very incomplete picture.
What are the results of climate change so far in terms of its impact on topsoil loss and topsoil productivity, and why does this matter?
Well, I'm not quite sure myself what that link is. It's not my area of expertise. I mean, part of the problem we've got is the use of fertilizer use. We put a lot of nitrogen on fields, things like that. A lot of that is not even used. It just goes into our waterways. That causes problems downstream, like the dead zone, right, in the Gulf of Mexico is related to this sort of thing. Now, when we look back in the past, remember the old Dust Bowl, right, of the 1930s, and that's because we had bad agricultural practices, and that was coupled with a period of drought. Now, I think we learned a whole lot from that in terms of different farming practices. But sure, you have a flood or big erosion event, something like that. That can have a problem. My understanding of this is that the bigger issue is sort of the unchecked use of fertilizers, nitrogen especially. That's really the problem, rather than the degradation of the topsoil itself.
What are the results of climate change so far in terms of its impact on water shortages, and why does this matter?
Well, as I've indicated before, as the climate warms, the hydrologic cycle is going to change. It's going to become more intense. Now you'd say, well, the more intense hydrological cycle, you have more precipitation. Well, it turns out if you have more precipitation over here, that can lead to drought over here because of the nature of the way the atmospheric circulation works. Areas that are already dry are probably going to get drier. Areas that are already wet are probably going to get wetter. And we're already seeing some of these effects. If you look at something like wildfire in the West, it's probably a combination of a number of things. Climate change and forest practices. It's usually not just one thing or another. There's usually a number of coupled issues at hand. So water shortages in that sense. Water shortages in the sense of impacting agriculture. Again, we're probably going to have to be looking at changes in agricultural practices as they move along. But let's not be gloom and doom about this. We can get a handle on this.
What are the very most powerful 5 action steps we can take immediately to stop climate change?
Well, I'd say the 5 most immediate steps we can take, I would say, go solar in terms of your electrical production, go wind in terms of your electrical production, because that's really just secondhand solar. I would say eat lower on the food chain. I would say energy conservation. And the 5th one I would say is change the mindset. If we make it clear to our kids and our grandkids that energy conservation is really a good thing, that helps. Because if you say, well, you turn the lights off when you leave the room, or you turn the heat down when you leave the house, these are all tiny, tiny things in and of themselves, but they have the effect of changing how we think about energy. And if we're going to get together and beat this, we've got to change how we think about energy and energy use. And so a lot of that is just education. That's the 5th one, I'd say.
What aspects of climate change are we most likely to notice first?
Well, in terms of climate change, what we're likely to notice first, myself being an Arctic climate scientist, well, we're already seeing it. And the most visible change is, for example, the loss of the Arctic sea ice cover, something I've studied for a long time. It's very visible. It's very visceral. I think a number of us are familiar with the iconic image, say, of a polar bear standing on a melting ice floe or something like that. But it is very visible. It's very visceral. And the thing is, we'd always known that the Arctic was the place where we were going to see climate change first. and where it was going to be most pronounced. And here it is. It's a case where we sort of hate to say we told you so, but we told you so.
What happens when you explain this information to world leaders? Do they listen? Do they believe you? Do they care?
Well, do our world leaders care? Do they even listen? It seems that it depends on the leader. The current leadership in the United States does not want to hear this because it is very inconvenient, because the idea is that addressing climate change is going to hurt us economically somehow. Other world leaders seem to have caught on in terms of trying to combat climate change. Europe is way ahead of us. It really depends on the person, and hopefully it won't get to the point where we have to have some catastrophic event for people to suddenly wake up. Sometimes that seems to be what it takes, but it seems to depend on a leader. But I see the momentum growing now. I see that there's a shift now, that attitudes are changing, because you can't ignore what is happening anymore. You can't stick your head in the sand on this anymore. So I am optimistic that we're turning the corner.
What is the significance of the melting Arctic?
Well, the significance of the melting Arctic is, number one, it's a warning signal. We'd always thought that this is where we'd see the change first, where it would be most pronounced, and that's exactly what's happening. So again, as I said before, it's a case where, we told you this was going to happen, and here it is. So it's kind of that red flag out there telling us that, hey, climate change is real, and it's happening just pretty much the way we thought it would unfold. But in terms of impacts of the melting ice in the Arctic, we already touched upon the issue of sea level rise. The Greenland ice sheet is losing mass. Arctic glaciers and ice caps are losing mass. They're melting down, and that's contributing to sea level rise. We're losing the sea ice cover. Now that doesn't itself affect sea level rise, but the loss of ice is very tied in with this thing we call Arctic amplification, which is the observation, and this is something that was predicted a long time ago, the observation that the warming that we're seeing across the globe is most pronounced in the Arctic. The Arctic is warming at something like twice the rate as the rest of the planet. Why does that matter? Weather impacts. If we look at what drives the weather machine in the first place, why we have storms with warm fronts and cold fronts and things like that, it's Mother Nature's way of transporting heat from areas where it's warm in the tropics up into the Arctic where it's colder. In nature, everything wants to go down the gradient from high temperature to low temperature. And when we have a storm come through, it's doing its job of mixing that air, transporting the warm air poleward, the cold air equatorward, mixing the air properties up. That's what the atmosphere does. And it's all driven on the predication that the Arctic is cold and the lower latitudes are warm, because, of course, the Arctic doesn't get as much solar radiation, sunlight, as in the south. Well, we're warming the Arctic at this outsized rate. Well, that means we're messing with that temperature gradient, that basic temperature difference between the low and the high latitudes. We're messing with it. If we mess with that temperature gradient, something's got to give. The atmospheric circulation has got to respond to that and adjust to that. There's very good evidence out there that this Arctic warming, this Arctic amplification we're talking about, is actually having impact on what we call the jet stream, which is then having impact on weather patterns right down here in mid-latitudes. It's still a controversial issue, but many scientists are working on it. The one other issue about the Arctic is what we call permafrost carbon feedback. If you look across the Arctic, most of the Arctic is underlain by permafrost. The land areas are underlain by permafrost, perennially frozen ground. There's a heck of a lot of carbon in this permafrost. Old frozen peatlands, things like that. There's more carbon stored in these permafrost areas than is in the atmosphere today. We're warming up the Arctic. What happens to that permafrost? It starts to warm, it starts to thaw. When it starts to thaw, the little critters in the soil, the microbes, become active. They breathe. What do they breathe out? Carbon dioxide, methane. So in other words, you warm things up, you thaw the permafrost, that result in more input of carbon dioxide or methane to the atmosphere to further the warming. It's another reason why we should be thinking about what's going on in the Arctic. The issue with the permafrost carbon feedback is that once it's started, it's hard to put the genie back in the bottle.
Can you expand a little bit more on the title of your book,
Yeah.
Brave New Arctic?
Well, Brave New Arctic, actually I didn't choose that title. I had a different title, but the publisher chose that title. I thought it was a little Aldous Huxley-ish, right? Brave New World, okay, but it does resonate a bit because it is a new Arctic and we're bravely marching forward into the future, not quite knowing where we're going to end up. But again, as I said, that's what this book is all about. It's about this transformation of the Arctic, how it happened, and how scientists came together to understand this. And the pitfalls along the way, the stumbles that we made along the way. It's really a story about science and about scientists. It really tries to humanize science. Hey, you know, scientists are people too.
What were you thinking of calling it?
The New Arctic Explorers, that's what I was going to call it. Because we had the Arctic explorers of old, the 19th, say, and 18th century. And now we have the new generation of Arctic explorers who are the scientists who are trying to understand the changes that are unfolding in the Arctic. I thought it was a nice title, but the publisher, we had some talks on this, and they thought that this other title would be better. So, again, I thought it was a little Aldous Huxley-ish, but c'est la vie.
What proof do you have for people that say climate change is a natural thing?
Okay, well, the issue, of course, is Earth's climate has always changed. It's been changing ever since basically the Earth was put together. But the thing about past climate change, or any climate change, is that it has a reason. Every climate change has a physical reason driving it. It's not as if Harry Potter can flick his magic wand and say climate change. It doesn't work that way. All climate change is caused by something. What could be that something? In the past, it has been anything from variations in solar output to variations in the Earth's orbit about the sun, what we call Milankovitch effects, to periods of continental drift or volcanic eruptions, asteroid impacts, right? Any of these can force a climate change. So climate change never just happens by itself. But of course, past climate change is what we call natural, right? It wasn't caused by humans, but it still had a cause. Now, the most recent climate change that we're seeing now over the past century or so, it absolutely has a cause because the concentration of greenhouse gases in the atmosphere is rising. And we have understood how certain gases in the atmosphere absorb what we call infrared radiation, certain wavelengths of it, and re-emit that radiation. We've understood this for more than a century in terms of how these gases behave. I mean, this is, there's all kinds of modern technologies out there that are based on these sorts of understandings. Everything from microwave ovens to heat-seeking missiles to what we call infrared spectroscopy. So we know what greenhouse gases in the atmosphere do. We've understood that for a long time. Well, now they're rising. Why? Why are they rising? Us. Our fingerprints are all over that in terms of, for example, what we call the isotopic composition of the carbon in the atmosphere. No doubt it is us. No doubt that if we add greenhouse gases to the atmosphere, it will warm. That is the climate forcing today. All climate change has a cause. We know what the cause is of this.
Who is the IPCC? What have they said about climate change? And do you think they're being too conservative?
Well, the IPCC is the Intergovernmental Panel on Climate Change, which is formed of scientists from all over the world to try and come up with these assessments of what the climate is doing and where it is going. It's authored by thousands of scientists from all over the world, and it's intended as sort of a consensus view. A number of what we call IPCC reports have been put out. We're now moving past the 5th to the 6th IPCC assessment. And my view, having been part of this process through the years, it's a fairly fair consensus on what is going to happen. Certainly one can always nitpick parts of this. I think there's still a lot of certainty on what the rates of sea level rise are going to be, because there's a lot about what's going on in Antarctica that we don't quite understand. Maybe conservative on that side. But I think overall the IPCC is a very fair assessment. Sure, you can criticize parts of it, nitpick parts of it. It is a human process put together by real people and real scientists that maybe have their biases. But I think overall it's been a very, very successful effort, and we should not dismiss it. We should embrace it.
Why are universities talking about this more and taking aggressive action?
Well, why are universities talking about this more? Of course, this is where a lot of the research is done. Now, of course, there's research in government, like NOAA, for example, and NASA, for example. But a great deal of the research in terms of climate change is done within the universities, such as my university. I'm from the University of Colorado, which is actually a national leader in environmental sorts of studies, climate studies. But this is just what universities do. I mean, these are seats of learning and understanding. We and universities work often closely with scientists in the government. We partner with each other. But it's just universities, those are seats of learning. This is where a lot of this research is done.
Why aren't politicians talking about this more and taking aggressive action?
Why aren't politicians talking about this more and taking aggressive action? Some of them are, right? But many are quite reluctant because part of their constituency maybe doesn't want to hear this, the issues of climate change, or they don't want to take action because it'll be viewed as having some sort of economic impact, against their interests. And so, unfortunately, our politicians seem to be beholden, right, to industry views too often and not thinking really about the bigger picture. But it depends on the politicians. Our current administration is not particularly friendly in the sense of addressing climate change. Let us hope that the next one has more eager ears.
Why aren't the scientists talking about this more and taking aggressive action?
Why aren't the scientists talking about this more? I don't agree with that. I think the scientists have been on the forefront of this, of getting the word out. Now, there's been an evolution among scientists in the science community. For a long time, scientists, most of them were content just doing their work and their research in their office or in the field or wherever they do it. And really not reaching out. They communicate with other scientists through peer-reviewed papers and things like that, or at scientific conferences. But we've seen a big shift in that over in recent decades, that most scientists understand now there's more to it, that you have to be able to reach out. You have to be able to try and communicate the science to public and to policymakers. So we're seeing a big change in that way. Not all scientists, certainly. There are some who really can't deal with this. There are others like myself who have taken it on themselves to be much more vocal. So we're seeing big shifts. We're seeing big shifts in other ways. For example, science, like climate science, used to be very a male-dominated thing. No longer. I look at the class I'm teaching now. It's about 35 undergraduates, more than half is women now, right? You're seeing this shift now in that it's understood that, what you're appreciated for is what's up here and how you can communicate that. So the whole science community is really changing, and I think we've been very, very strong in being outspoken about what is going on. The challenge is communication. Too many scientists talk like scientists. And they talk in their jargon and things like this, and it goes over people's heads. No, you've got to be able to connect at a different level.
Why is the United States government not concerned about climate change?
Yes, well, I would say that parts of the United States government are concerned with climate change. Our elected leaders, many of them are not. When we say the United States being concerned, yeah, our armed forces, Department of Defense is all over this. The Navy is very well aware of climate change and concerned about it. As I mentioned before, why? One thing, sea level rise. Naval ports are at sea level. What's happening in the Arctic where we lose the sea ice cover? I've had Navy people talk to me, and one of them said, hey, I don't even care why we're losing the sea ice, but what I see now is we have a blue ocean there, which we didn't have before. I've got to deal with it. The Army is very interested in this because of, in terms of changes to the landscape, the operational environment that they call it. So it depends on who you talk to. But for example, DOD, Department of Defense, they're very, very pragmatic about this. They see what they see. Unfortunately, our elected officials seem to be less receptive to the views.
Why isn't the EPA talking more about this and taking more aggressive action?
Well, the EPA has been aggressive. However, the EPA has been muzzled to a certain extent by this administration. Some have argued that maybe the EPA has overstepped in some areas. That's an issue for a different debate. But the EPA, we entrust them on enforcing these environmental regulations. And what shocks me with this current administration is that we're seeing those regulations eroded. And that is exactly the opposite of what we need to be doing right now.
Why isn't the media talking more about this?
Well, again, why the media isn't talking more about this, I think the media is. So I think that question is, the premise is incorrect. The media is all over this. Just watch CNN or something like that. Now, of course, you might want to look at Fox News, right? Maybe they have a different view on this thing. But I think the media has been all over this, and especially on some of the impacts of climate change. So I don't think it's fair to say that the media has really not been more outspoken about this. Their job is to report the news, right? I'm interviewed on a weekly basis, sometimes a daily basis, depending on what's happening, on issues of what's happening in the Arctic. People want to know. So I don't think it's fair to say that the media has not been all over this. They have.